Let's take a look at this problem which deals with probabilities and z-scores. The problem is given in this area of your screen. What is the probability of a score falling between a raw score of 70 and 80 given the information provided below? And they give us a mean of 75 and a standard deviation of 6.38. Okay, now I want to jot in two numbers here. The lower limit is 70 and the upper limit is 80. And then we need to calculate the probability of the lower limit and the higher limit. So let me show you how I solve that one. If we click on the normal distribution function, we simply jot in where the variables were given. So in cell C6, we use the lower limit. That's what we're concerned with, 70. The mean was given in cell C3, which was 75. The standard deviation was given in cell C4, which is 6.38. And you need to set the cumulative to 1. And when you do that, you come up with a probability of a lower limit of 2.166. Now, that's the z-score for value 70. All right, we use the same procedure to come up with the probability of the higher limit. And I'll just pop it on the screen and you'll see we're using 80 now, the same mean of 75. Standard deviation is still 6.38, and we leave cumulative again set to true, or 1. Okay? So then what we need to do is compute the difference, and when we compute the difference, we come up with the probability of a score falling between a raw score of 70 and a raw score of 80, and that's about 56.7%. Right? You see that on the screen right here. Okay, now if you were concerned with the area of the mean to the z-score, what you would do is you would take the upper limit, the 78.34, and subtract 50%, because remember the mean is at the halfway point, or 50%. Okay, and the probability that the score falls above 80, you would take 1 minus the cumulative probability of the higher limit, and that comes up with about 22%, or 21.7%.